On the workbench today I have a Sony DA4ES. An STR DA4ES is the actual model number of the unit. The complaint of this unit is that it shuts down when it gets warm. So I'm thinking probably a bad connection somewhere, maybe in one of the driver stages or the preamp stages. So before I even plug this unit in and apply power to it, if it does turn out to be that there's a cold solder connection that we can see, the last thing I want to do is to have that connection open while the unit's under test, because when you have a fractured connection that can lead to semiconductor failure. So before I even get into the point of plugging this thing in to test it, I'm going to take the top off it, take it apart, as they say, see what's going wrong with it, look for anything physically that could be causing this, like a fractured solder connection. We'll do a full inspection of this unit and then we'll power it up. As you can see, this unit was out a few years before HDMI became available, so there's no HDMI inputs on this. It's got two sets of component in and a component out, and a bunch of AV inputs. And we've got 4 video inputs, a second room video output, a monitor output, and we've got our front speakers A and B, center channel, and our surround channels, surround and surround back. So this one actually is a 7-channel receiver that would receive the signal through your digital input, your coaxial or your optical input. So this was a good stereo receiver that does not have HDMI switching, because it was made just before the receivers with HDMI switching hit the market. So we're going to find the construction quality of this thing is actually pretty darn good. This unit is by no means a lightweight unit either. This thing here weighs in probably about 60 pounds. It weighs a ton. Look at the size of this big iron transformer in here. Good size filter capacitors. And just an overall really nice unit. All discrete components. I'll get you some close-ups here of some of the components on the boards here. So looking down to the top, here's our discrete output transistors for all of our channels on both sides, mounted to 2 very large heat sinks. There are no fans in this unit that I can see. Some manufacturers choose to put fans on it. Sony just have big solid aluminum heat sinks with lots of ventilation on the top and the bottom. And here's our digital board over here. This is where our digital processing takes place on this board here. I don't think we'll find a problem on this. I think our problems we may have regulator problems. With some of these regulators that are soldered down, they have a tendency for the solder connections to crack on them. So we're going to inspect them and basically just do a full inspection of all these little connections here. For a lot of these big lugs have a tendency for the solder to fracture on it. So I was going to get the bottom off this thing so we can access the main board. One thing I like about Sony is one of the companies that was forward thinking as far as service goes. You could remove the bottom and access the circuit boards, which is something I can't say all the manufacturers followed through on. Some of them, like Yamaha, you'd actually have to remove the board from the cabinet because the base was not removable. So Sony is to be commended for this design, because as far as serviceability, it makes their equipment very, very easy for the serviceman to access to perform any repairs or maintenance. Just remove all the screws and the bottom should come off. I also have to remove the feet, I think, because I'm pretty sure the feet on this one, they screw right into the chassis as opposed to just into the base. Maybe not. These ones the screws. Looks like the screws just go into the actual metal plate on this. On some of them the screws actually went right into the main chassis, so you had to remove the plastic feet as well. But it looks like I'm going to get away on this one, and it's not going to have to. They're not going to have to be removed because they are actually attached to the base itself. So we'll remove all the screws. One more down here. Yep. And the bottom plate should lift away, and then I can get in there with my magnifying glass and look for any obvious broken cold solder connections, which was a very common problem on a lot of these Sony units. I have to admit that I was kind of fooled there initially. These are actually dual transistors. They call them ICs. Oops. IC 502 and IC 501, IC 503, IC 654, etc. If you look down here on the board, it'll show you which output. This is the front left. Center channel, these two. Front right. So they got 5 leads on them. They're actually an IC. I guess they're probably a Darlington transistor inside there, or dual transistors. And the same as on the other side. So we have our 3 channels here, our left, center, and right, and then on the back side there's 4 channels. You see 2 of them down here for the rear left, surround right, and rear right. And they are driven by ICs down here. These are the driver ICs, and these are the ones that I suspect may have the solder connections on them. So we're going to take a look. I'm just going to wiggle these things and see whether we can actually see any movement on the other side of the board, because this is the most likely cause of faults on this particular unit. Okay, so we're looking at IC 501 here. Take a look at the pin number 15. I'll zoom the camera in a little bit. Whoops. Well, I'm sure you can see pin number 15 here. When I'm wiggling the chip, I'm sure you can see that moving. Okay? You can see them all moving. This is bad solder. And this is what's going to be causing the problem on this unit. Is what happens is when this thing heats up, these solder connections are going to expand and they're going to fail. And then you end up with an incorrect drive voltage and the amplifier is going to go into protection. So this is exactly what I thought I was going to find when I got into this thing. That's why I didn't want to put power to this thing prior to actually inspecting it, because I saw so many problems in the field with when they use these integrated power modules, as they call them, IPMs. Basically, that's your whole amplifier driving circuit, and that's driving the output transistors, or in this case, the output ICs. They produce a fair bit of heat, and those ones are bad. And we look over at the next one here. I'm sure these ones are also probably bad. Let's just try moving these ones as well. Go to the next one over here, and that would be, where is it? I can't find it here. Is that one there? Yep, pin 15. You can see it cracked all the way around. Right there. See that? You can see the crack. There's our problem. And there should be some more of these things in here as well, I think. Anyway, a blind man could see that one. So this thing's going to get some resolder work done on it, and then we'll put it under test. I'm just moving my camera back a little further so that the thing will actually focus, because I was just a little bit too close for the full telephoto focus, so you can see that there. Yeah, even along pin 1 here, where we put these ones here, you can see the fractures all the way along here. That's going to be the problem with this thing, and I bet you that's the only fault that this amp has got. We'll also check the other regulators. I got to pull that board out to get at that, but we'll check them as well, because that's where the problem normally happens, is on these type of connections. And somebody who was critical about the amount of solder that I put on, and there's been a few people that have been critical about telling me I put too much solder on a board. Well, the reason I put a good amount of solder on boards, especially pins like this, like these high power pins, is it helps dissipate the heat. If there's not enough solder on it, you get thermal expansion, thermal contraction, and it'll crack the solder. And that's exactly what happened on this. So we'll just start over here. I'll resolder this IC first. Try and keep my light out of the way so you guys can see what I'm doing. It's also bad there because you had a crack on that one. looks like it's touching the lead above it, but it's not. From my angle, it almost looks like this is shorting out here. So make sure that we just move that. We'll just melt that end and move it out of the way just so I know it's not going to touch. There. Now I can see it's not touching. Okay, that's IC501 done. Let's move over and do this next one here, which is also got bad connections on it, so we'll just move over, get back down in front of the scene and go to work on this one. Trying not to block the shot too much with my magnifying glass here. Maybe I'll do the top row first and then come back and do the bottom row. Okay, we got a regulator over here too that looks kind of questionable from my angle. I don't know how it looks on the camera, but from where I'm sitting here, this regulator looks like it needs to be redone. Okay, that looks a lot better on the power board here. So here are the ones that we redid. We redid IC501, IC651, Q951, Q952. Those ones were the worst that I've seen on this board. We're going to now look at some of the regulator ICs or transistors or whatever they are mounted on these heat sinks, but to get at that I have to actually remove the digital board. To remove the digital board, I believe it's these screws here on top. There's 6 of them. And then the board should slide forward and out. And there should hopefully be enough slack on the ribbon cables to actually get the board sitting on top of the unit to work on it. One other thing we are going to look at is grounding screws between the different boards. Usually there's a screw that's grounding the board to the main chassis, and sometimes they have a tendency to work their way loose as well. I don't know if this one's going to be that simple. Some of them, yeah, this one has a grounding screw down here, for example. If we look at this other board, you'll see grounding screws that have got a tab on them, and they need to be tight, and that one is tight. That was a common problem on a lot of the old sets, is that ground screw would come undone and it would cause the amplifier to go into protection. I don't see any on these other boards here, so they must be grounded with wires, which is how they should be grounded. Okay, there's a wiring harness here. We can open this up, and that'll allow us to slip out our ribbon connectors that connect the digital board to the front board. There's a little bit of slack on here, so we should be able to slide the board forward and lift it out, I think. See, making sure that there's nothing else holding it up here. Just have to undo a couple of wire tie downs to give us some slack. And then the board should slide out. Couple more on the bottom that we have to undo, wire tie downs, just to give us some slack in the wiring, and then we should be able to slip the board out and up. At least that's the plan, so that I can access the big, large heat sinked regulators on the bottom. To protect these ribbon cables, I'm just going to unplug them. I don't want to damage them, so we're just going to unseat them. And I'm going to label them front and back so I know which one goes where. So this cable here being the front cable, I'll just put an F on that one. And this is the back cable, so I'll put a B on that one so that I know where they go. Not that I'm going to get them mixed up anyway, because looking at them, they're two different sizes. One's bigger than the other, so we're not going to get them mixed up. But just for the heck of it, if you run into those situations where you do have connector cables and they're the same size, it's always a good idea to mark them. I'm just going to remove the AM/FM tuner just to give me a little more clearance. So there's 3 screws on the back. The AM/FM tuner now can be lifted out of the way and unplugged from the board with this connector here. That way you've got more room to work on this thing, because it is very tight. As you can see, there's not a lot of room on this board, and for that matter I might even want to consider unplugging some of the other connectors, but we'll see whether I can get this out of here without it. I'm going to probably have to unplug a few more of the connectors that are on this board here. So this one here is the same size as the tuner, so I'm just going to mark the connector. I'll mark it with a couple of little lines that go right onto the ribbon cable so that I can line it up and I know which one it goes to. Now I can unplug that ribbon cable and get it out of the way. They don't have a lot of room in this unit. It's really quite crammed here as far as moving anything around, but it will come out. And I did pull out another connector from the bottom that came out of one of the boards on the bottom that I wasn't expecting, but we'll have to get that back in later. But right now it's out. Okay, I don't need to really take this thing out any more than this. I just want to be able to take a look at these connectors along the edge here. So we'll just look at these with the camera, see how they look. That one looks okay. Move down to the next one. These will kind of look okay on this. I don't see any obvious cracks on any of these ones, which is good. I'm going to put that one right on the end there. It's hard to tell, my camera really won't focus very well. Maybe more light might help. It doesn't look to be too bad. I would say that these will look okay on this board. I don't see anything that's jumping out at me as being a cold solder connection. Just from the ones that I've looked at, they all look to be pretty good. So we'll reinstall the board, and then we can get this unit back and assemble it and test it, or maybe not assemble it, but at least get the unit hooked up so that I can power it up and test it. So now I have to get all these connectors back in here that I took out, which is going to be the fun part. Tell you, if you accidentally unplug this one down here, you're going to have a hell of a lot more trouble getting it back in than it was taking it out. You got to remove all the connectors off the board so you can get your hand in here to reconnect this connector that easily pops out. So if you're going to pull this board, disconnect all the connectors off it that you can, and don't allow the one on the bottom to pop out. Otherwise you'll be here for a while disassembling everything to get this one stupid connector back in. I always need a kid in here with tiny little hands to install this connector. This is ridiculous. It's right up against the side, and it's in just such a really hard place, it's almost impossible to reach it. 20 minutes later, I have the connector reseated. That is not an easy sucker to get in there. So my advice, don't unplug it. And now I have to reconnect all the other plugs I had to take out to get the board out in order to get at that connector. Got this one that goes over here. That one that goes down there. There's two more. With the board sides in place, all the tabs on the side here will line up like this. Okay, once the tabs line up, it's then time to put the screws back in to secure the board in place. And now we can start to reconnect the ribbon cables that were taken out too in order to work on this thing. And I mark these all so I know where they go. Like I marked this one with an L because it's the lower of the two. And I marked this one with a U because it's the upper of the two of them that are the same size. That one I marked with a couple of little marks. I also put them on the connector itself so that I would know which one they went to. And then there's the tuner that has to go back in, and it has its connector up top here. Tuner's held in place with 3 screws. And then we can just tie down our wire ties. Oh, there's the 2 more connectors over here I gotta get to as well, but don't want to forget about them. And then the tie the wires in place with the wire ties, just keep them out of the way. The wire ties are actually secured to the board itself. So that's those 2. We've got our other connectors here, front and back. I marked them with an F and a B, even though I'm not going to get these mixed up because they are physically different sized ribbons. I did mark them anyway just so that I would know where they go. It's always a good idea to get in the habit of marking connectors when you take them apart, just so there's no confusion when it comes time to put it back together. Looking at this unit, I've neglected to check this board here. There's some more of these big ICs on this board here, so I'm going to pull this board and check because there's more driver ICs on here which I've neglected to check. So let's take a look at those before we power this thing up. A couple screws here, and this is actually a module, so it will unplug from the other board. as you can see, we have more of these large ICs that need to be inspected. Yeah. Look at IC 601, look at them all. Holy shit. They're bad. This other one here's also going to be bad over here. Where is it? It's right where my thumb is, if I can't see it. Gotta find it on camera. There's the other one there. And I'll wiggle that one too. And it's not as bad as the other one, but it's got some broken joints. I just happened to spot that when I was looking at it before putting it together. I was looking at it and I thought, wait a minute, we got a separate driver board on here. So they're going to have some more ICs on this one. And sure enough, as you can see, they're no good. They're no good. IC 601. Got the iron back out here and get it warmed up. Some light happening here so I can see that I'm moving. Much better. There. No more broken connections. Let's inspect the connectors, as they also ones that are known to go bad. So we reconnect up the audio and power connectors to take the signal for the power input and signal inputs for this board into the board. And then the board, there's two plugs on the bottom here that have to line up. Couple screws. Get the wire ties around the wires to hold them away from any components that get hot, such as the transistors. Now we're ready for testing. Whenever I deal with a high power amplifier, before I hook up speakers, because a high current amplifier like this can pop speakers in a second if I've got any DC output. So I always test it with headphones first, and I'm not getting any sound with headphones. I turn up the volume, and I got no sound coming out of my headphones unless I crank it all the way up, and then I get some distortion. So I'm going to go through. Remember the IC on the bottom here that was, oh, I can hear that when I touch it with my finger. I can hear it in my headphones. If I go through and I hook up, I'm just going to look at the input going into the IC. So if we look on the scope here, here's my left channel input. As you can see, we've got lots of audio here, and I've got control of it with my volume control. And if I follow it through the circuit, it goes through a capacitor here, coupling capacitor, and it goes into the chip. This is our driver chip. You can see the sound on the scope, but I have no output. I can hear something when I touch that, loading in my scope. I don't have any output from this IC. So either the voltage isn't correct going in. We'll check the voltages. When I touch that, I can hear it on the. I can hear a thump. I think that's probably the output that's going to the amplifier section. As I suspect, they are all NEC made ICs. They're a UPC 2581V. Let's go get the data sheet on that and see exactly what the pin in and pin out is on this, so that I can actually run some tests on it and check for voltages before we go about swapping them. Here's something that kind of pisses me off. You want to print out a data sheet. So you look up your data sheet and you hit print, and you get 6 pages, all totally useless. Everything you want is on one page, but you know, the web page has to ship you the 6 pages of crap, which you can't even bail out if it doesn't ask you, what page would you like to print? No, it just prints everything. Waste all my paper and all my toner. Okay, we've got the data sheet here. I'm going to plug the other daughter board back in. We're going to do some voltage measurements, make sure that we're not missing a voltage to this IC. Make sure that because if all of our voltages are correct and our input's there and our output's not there, then we know that we have a bad IC. But we also could be missing a voltage. So let me plug the daughter board back in, and we'll take some voltage measurements. Okay, we've got our data sheet here. Our muting input is number 1. We've got our drive output on pins 2 and 3. A composite output on pins 4. Pre-drive, and our in is on pin, ground is 7. In is on pin 8. In 1 is on pin 6. In 2 is on pin 8, and this is our composite output 10. And then our drive output 11 and 12. And our 13, 14, and 15, these are our VCC1, VCC2, and VEE. These are our power supply voltages. So let's take a look and see whether our power supply voltages are correct. So turn on the power. I remember, if you remember, it was pin 14 and 15 where the connections were cracked before. I just want to keep this camera where you can see what I'm doing and see the voltages. So we'll look at pin 14 first. Let's get my light in the way here so I can see what I'm doing. So pin 14 is this one here, and I got no voltage on it. That would explain why it's not working. What about this one here? I got no voltage here either. I got no voltage. I got minus 53 volts on that one, which is the VEE. But my VCC1 and VCC2, which is pin 13 and 14, I've only got 0.6 volts. That looks a little low. But on the other IC, minus 53. And again, I've got no voltage here. So, we have a problem. We gotta find out what that voltage is supposed to be and trace it back and see why we don't have it. So the voltage I'm going to be missing is my positive 55 volts. Because we've got the negative 55 here. That's our VEE. So our VCC should be the positive voltage. And we have it here. There's our 55 volts. So I'm just looking through the circuitry here and following it to see where it goes. Because it's obviously it's going to go probably through our resistor somewhere, and a takeoff for that other supply. Our B plus comes up here. and that's our negative supply. The B plus comes up here, and this might be, that may be a resistor right there. It's not marked anything on the board, but I think we may have a resistor that may have gone open, because there's that 0.6 volts, which is what I'm seeing here. Just make a test. I'm just going to disconnect it and let the power drain out of the capacitors here. You'll see that the voltage will drop off 48 volts and minus 46. So we'll just unplug that plug on the top side here to kill that power, as I don't want any power on the circuitry. I bet you we've got a little resistor that's popped. Okay, now back to looking at this thing. We've got no voltage on here now. If I go to ohms mode, I'm thinking that this is I think this is probably a resistor here. And let's just see if I go to pins 14 and 15 whether we have a connection. Yeah, there's definitely a connection across there. It's not a short or anything, but how many ohms have we got here? We're talking about 1.8 mega ohms. But this definitely, I think, is a resistor that's open. 18K. There's probably one on the other side as well. I think that's probably a resistor. It's coming up at 18K ohms. I'm just going to turn the board over and take a look and see what it is. I think it's probably a resistor. It's not open, and I'm sure it's a lot lower value than 18K. So let's just take a look and see what it is on the other side. Yes, it is a resistor that I pulled out. When I measure it, it's measuring 18K. But I don't know if you're able to see the color coding there. We'll zoom in here and see if you can see the color coding. Okay. It's brown. Looks like brown, black, black. So that's 10 ohms. We're measuring 18K. That resistor is open. Now I don't have a 10 ohm resistor exactly in a little quarter watt size that was, or 1/8 watt, I think it was a quarter watt, but I do have a couple of 4.7 ohm resistors. So we'll put two 4.7 ohm resistors in series. That'll give us what, 9.4 ohms. That should get us in that range that we want. It's just being used for protection, and we'll see whether that will get this unit up and running, get our voltages back, and get the unit up and running again. So let's get this soldered into the board. Okay, it goes right down in through here. That part number, in case you guys want to see where it is. So that resistor is R591, and it's just a fusible resistor in the protection circuit for the ICs. Okay, we've got everything resoldered back in. Reconnect our power connector for our power supply. Turn on the power. Should we try it? I'm almost nervous to try this. You can see my plasma still working in the background here. To all you guys out there that say, yeah, I can't fix a BGA connection with a heat gun. Power. Do we have sound? 5, 4, 3, 2, 1. I would say we have sound. It is working, so there you go. Nice Sony DA STR DA4ES was dead. I was told When it overheated, it shut down. Well, we know why it shut down when it heated up. Solder connections on the drive ICs went bad. It also kicked out a little 10 ohm fusible resistor. We replaced the resistor, resolder all the connections, unit's fixed. Now the unit will go on my test bench and it'll stay here for a while, get good and hot to make sure we're not going to have any future problems. But and again, initially I thought maybe we had a bad IC, but that's why I pulled the data sheet, so always check to make sure your voltages are there. If the voltages had been there and the IC was bad, I could have swapped one for another and it would have fixed it, but you always check to make sure that you don't have a missing supply, and in this case we did. Our positive supply, we had a negative supply here on pin 15, but our positive supply on pin 13 and 14 was missing. Thanks for watching. We'll catch you in the next one.